Welcome to this solution video of paper 42, Mechanics of Cambridge International Examinations, February-March 2025. If you like this video, please give it a thumbs up, share this video with your friends and subscribe to Math United. The marking scheme of this paper is not out yet. So if you find any calculation mistakes, I am sure that there is no method mistakes. So if you find any calculation mistakes, please let others know in comment box. Appreciate this video if you like it. Thank you very much. Question number 1. It says that there are 3 coplanar forces of 40 Newton, 30 Newton and x Newton act at a point in the direction shown in the diagram. Given the forces are in equilibrium, find the value of theta and x. So straightforward question, no challenges in this one. So what will we do? We will just divide the tilted force into its components, which is only x, no one else. Where we have the angle, that component becomes the cos component of the force. It will be x cos theta. This will be x sin theta on the opposite side of that force. And that's it. We'll equate the horizontal forces and vertical forces and we should get our answer. So first we'll equate the horizontal forces. So let's say resultant in x direction is we can say that because they're saying it is in equilibrium, so we will equate 40 Newton and x cos theta. So we'll write x cos theta equal to 40 newtons. No need to write newtons, 40. Okay, similarly x sin theta will be 30. Now we have to find theta, so it's better that we divide both sides and it becomes tan. A tan is sine over cos, so I will divide this equation by this equation. So x sine theta over x cos theta, which is the left side of one equation divided by left side of equation divided by right side of that equation, 30 over right side of the cos equation. Okay, so the purpose was to cancel this x and x. So if x is cancelled, sine over cos is tan theta equal to 0 and 0 can cancel, 3 over 4, and theta becomes tan inverse 3 over 4. And just put this in a calculator and you'll get an answer. By the time I do this, I would again request you to like this video, share with your friends and subscribe to Math United. What I'm getting here is 36.8698. So I'll write it approximately 36.9 degrees. Secondly, they are asking us to find the value of x. Now, to find value of x, I'll put this in place of the theta and I can get x easily. But I'll do the another approach, which will give me a better answer. So what will I do? I'll square these both equations and add them, add this type. So if I add, square this particular part, it will become x square cos square equal to 1600, right? I square this, I square this. Similarly, x square sine square theta is 900. Let's add them, both the equations. So the right side becomes 2500 and here it becomes x square e, and we'll take x square common and cos square theta plus sine square theta will be inside the bracket, which is 1. Cos square plus sine square is 1. So x square equal to 2500. X will be the square root of 2500, which is 50 Newton. So we got x equal to 50 newtons, its angle equal to 36.9 degrees. If you would have put this angle into the equation, you would get something like 49.99, but not exact 50 newtons. That's why I preferred this method. It's worth 4 marks. It's good to show some work on this. The cyclist A cyclist is traveling along a straight horizontal road at a speed of 4 meters per second. Okay, so this is the road and the cyclist is traveling with 4 meters per second. Okay. When she passes through a point O, okay, this is the point O, she accelerates at a constant rate for a distance of 42 meters. So let's say the distance up to here is 42 meters and acceleration is constant. Okay, reaching a speed of v meters per second. So it was 4 meter per second. Acceleration, obviously v will be more than 4 meter per second because it's accelerating. Okay, she maintains the speed v meter per second for 50 more meters. Okay, 50 meters. That means the speed here is again v meter per second, and then decelerates. That means acceleration is negative but constant, right? 2 meters. Oh, they have written. So acceleration is minus 2 meters per second square in next few, but it comes to rest. That means v is equal to 0 here. The distance traveled while decelerating is 16 meters. So we have everything here. Find the value of v. What is the v here? So if we think of this particular part only, we know that u is 4 meter per second. V is v meter per second. S, distance covered or displacement in this case, is 42 meters. Alright, and acceleration we don't know. So we don't know this. So we don't know two things, v as well as a. So it's better we take this one where we know acceleration. So here the initial velocity is v meter per second. Final velocity is 0. Displacement or distance covered is 16 meters and acceleration is minus 2. So we know more things here. So it's better to use this one. So we know that v square equal to u square plus 2as. This is a kinematic equation. We can use this one. So v is 0. U is v actually plus 2 times minus 2 times displacement is 16. So 4 times 64 is the 1. So 64 positive is v square, because this is negative, it will go positive to the left side. So v becomes square root of 64, which is 8 meter per second. And they're asking the value of v only. Done. Okay. Let's move on to the next part, which is find the total time for which she is in motion from the instant that passes from O. So whole journey, what is the time? That is the question here. So we'll try to do that now. So first, let's make it in 3 parts. 1, 2, and 3. Here we knew most of the things, so let's find this one first. We know that v equal to u plus a t. V is 0, it stops at the last one, it stops in this velocity. We got 8 plus minus 2 times t. So 2t comes to the left side, so t becomes 4 seconds. Now this one is left. Okay, here it has constant velocity, means we started with 8, ended with 8. So we can use time equal to distance over speed in this case, because there's no acceleration. So we can use what we learned from our childhood. Time is equal to distance over speed. So distance is how much? 50 meters. Speed is 8 meter per second throughout. And it will be 6.25 seconds. Yeah. Alright, now this one. Here again we can use the v equal to u plus at. V is 8 at the end of this particular part. So 8, it started with 4. Acceleration, we don't know. And time also we don't know. Alright. So it's better that we find acceleration first and then we will find rest of the things. So let me do it. Okay. So in this we will use v square equal to u square plus 2as. V is 8, u is 4 plus 2 times, we don't know acceleration, but we know that it went for 42 meters. So 16 and 64. It becomes negative on the left side and this becomes 42 times 2, 84a. So 48 over 84 is the acceleration, which is 4 over 7 meters per second square. Okay. Now we can find time. Our purpose was to find time. And we'll find time here now. Okay. So v equal to u plus at. Now we can use that one. V is 8, u is 4, plus the acceleration is known now 4 over 7, and time we don't know. So when this 4 goes to the other side, 8 minus 4 is 4 equal to 4 over 7 t. So cross multiply 4 times 7, 4 and 4 cancel rather. So 4 times 1, 7. 7 seconds. So total time, they said total time, right? So our total time comes out to be 4 plus 6.25 plus 7, which is 10 plus 7, 17.25 seconds. Question number 3. An aeroplane is flying at a constant speed horizontally. Its engines are producing a constant power of this, okay, and a constant horizontal resistance of 25 kilonewtons. So flying horizontal, resistance is horizontal, so not a problem. Find the speed of the aeroplane. So we know that power by any engine is the force applied by it multiplied by the speed at which the body is moving at that instant, a specific instant, because it's constant speed, so we can take it for any time, right? So power is 5500 kilowatt. So we have to put watts equal to force applied is we don't know. We know resistance, but we don't know force applied, but we'll keep it that way. And the speed is 20, not 20. We have to find it. All right. We have to find the speed. So we'll write it as V. But to find this, we'll have to see that the net force MA is equal to the difference of applied force minus the resistive force, right? Acceleration is 0 because the speed is constant, acceleration is 0. That means the net force is 0. That means the resistive force is exactly same as applied force. That means in place of this applied force, I can use 25 kilonewtons times V is equal to 5500000. Okay, so V becomes divided by 25,000. 3 zeros cancel here, and that comes out to be how much? Times 2 times 2 times 0 meters per second. That is the speed at which the aeroplane is flying. Okay. There is B part also, which says the aeroplane then ascends 300 meters in 50 seconds. Ascends means goes up. Okay. So maintaining the same speed. The speed is still the same. How much? 220 meters per second. So it went up. That means the change in height is 300 meters. Time is 50 seconds. The resistance force is no longer constant. It is variable. So the more you are applying force, the resistance force is changing accordingly. Work done against this resistance force is for 300 meters. Yeah, 300 meters is this. Okay. So work done against resistive force is 270,000. Mass of the aeroplane is 60,000. So they've given mass also. 60k kilograms. Okay. Find the average power of the aeroplane's engine now. So it is not the one which was earlier. So we know that power is work done, the rate at which work is done, yeah, divided by time. So we know time. Where is it? Time is 50 seconds. Yeah. Only thing is that we have to see how much work is being done by applied force, because power belongs to applied force only. So for that we'll use energy equation, which says the work done by applied force is the sum of change in kinetic energy, change in potential energy, and work done against resistance. Okay. Change in kinetic energy will be 0. Why? Because they said maintaining same speed. There is no change in speed, and kinetic energy changes when the speed changes. So this is 0. Okay. Potential energy will be mg, and change in height. So we know change in height is 300 meters, and we know g, we know we can find this, and work done against resistance is 270 this. So we'll just place m, which is 60,000, g is 10, and height change is 300 meters plus 270,000. That's it. It will give us the work done by applied force. So it comes out to be total, if I use my calculator, 450 million joules. Okay, and that we will use here now. Power which is asked is 450,000 divided by time, which is 50 seconds, right? So it comes out to be 90. Yeah, 90,000. Not 9. Yeah, 9 million watts. Or you can say 9 megawatts is the same thing. Or you can write 9 times 10 to the power 6 watts, or 9,000 kilowatts. There are so many ways of writing the same thing. Question number 4. Two particles A and B of masses 0.3 kg and 0.1 kg respectively. The particles are attached with a string. The string passes over a smooth pulley. The particles hang vertically below at the same height of x meters above horizontal ground. The system is released from rest. Obviously this one is heavier, so this will come down and this will go up. Okay. Find the tension in the string and the acceleration of the particle. Let's find the acceleration of the particles by taking the whole of the system to find the acceleration. The whole of system will be decided by this. The net force, which is m multiplied by a, mass times acceleration, is the difference of applied force and resistive force. This is the common formula we use all the time. So m, mass of the whole system, is 0.3 plus 0.1, 0.4 a. Applied force will be, because it's going down, so this will be counted as applied force, the weight of this 0.3 kg, which is 3 newtons. And this 1 kg will try to take it this way, so it will be resisting. Nothing else. It is smooth pulley. The strings are inextensible, so nothing from them, only these two. So 2. 0.4a equal to 2, and acceleration comes out to be 2 divided by 0.45 meters per second square. Now, question was find the tension as well. Acceleration found. Tension. For tension, we will focus on any of these two masses. So let's focus on this one. Okay. So if this is the mass, the force that is bringing it down is 3 newtons. Okay. The force which is trying to stop it in this system only is the tension in the string. That's it. So we will just give the same acceleration to this and same formula we'll use, but the mass will be only this. We are focusing on only on this particular mass. So it becomes 0.3 times acceleration is 5 equal to applied force, which is 3 newtons, this one, minus tension. So tension will come here and this will come there. So tension equal to 3 minus, what is 0.3 times 5? 1.5, which is 1.5 newtons. This is the tension. This is the acceleration. Okay, let's see what next part says. During the subsequent motion, B does not reach the pulley. Okay, so B is going up, A is going down. So let me bring this there. So during the subsequent motion, this does not reach the pulley. Okay, so B goes up, does not reach pulley, but it has come down and hit the ground. Okay. Given that the greatest height of B above the ground is 1.2 meters, find the value of X. So greatest height, you will think that it will come down and hit this. This will go up and reach somewhere here, and this is 1.2 meters. From here, the greatest height of B is 1.2 meters. From here to here is 1.2 meters. So this is X, that is X. So it should be half of this. No, they're not expecting this from you. What they mean is this: it went X up by the time the A hit the ground, right? But since this B is going up, it will still keep on going up, and then it achieves a height of 1.2 meters. When this has reached ground, still the weight B will keep on going, and that becomes our X plus something more. Okay, let's call that Y for the simplicity's sake. So 2X plus Y is 1 by 2 actually, right? They're asking us to find the value of X. That means this Y has to be different from, and we don't have to find this. We have to find X's only. All right. So let's proceed this way. So I'll go a little up and try to do this. Okay. So let's find what is the velocity of the system when it reaches, B reaches here and A reaches the ground. What is the velocity then? Because it started from rest. So we can you use this one? Let me use here V square equal to U square plus 2AS, right? Acceleration of the system was already known to us, which was how much? 5 meters per second. That was the acceleration. So I will use that one here. Okay. So V square we don't know, we want to find it. U square was 0, 2 times 5, and S, how much distance has it, the system traveled till from here to here? X meters. So it will be X. So V square is equal to 10X. Okay. Now we want to know how much distance it travels after that, right? So distance is Y here, isn't it? What it read here, reached here. But keep in mind, by that time, this weight had touched the ground. That means the force of 3 Newton has gone. There is no force of 3 Newton anymore. Only gravity is the one which is resisting this motion here. So if I use the same thing again, V square equal to U square plus 2AS, we know that V square we got as 10X. right? And u square is, I'm sorry, v square is not 10x, v square is 0 now. Why? Because this is v in this case. It reached on the top and it will go there and stop. They said it did not reach fully. That it went somewhere and in between it stopped. That makes our final velocity 0 in this case. Initial velocity will be 10x, which was final velocity of previous part, 10x, plus 2 times minus 10 now. Because it's again it's going up against gravity. That is the only acceleration we have. And the distance it traveled was y. Okay, so now we know a relationship between 10x and y also. So we can write 10x minus 20y equal to 0, which means 20y equal to 10x, and that cancels both zeros. So x is twice the y. X is twice the y. Now we got our answer. That means if this is x, this is 0.5x. Yeah, because y is half of, that's what it means, y is half of x, right? So that means x plus 0.5x is equal to 1.2 meters. They said maximum it reaches is 1.2 meters. 2x plus y is 1.2 meters. 2x plus y is 1.2 meters. We will find x now, which is 2.5 x equal to 1.2 meters. So x is 1.2 divided by 2.5 comes out to be 0.48 meters. Question number 5. Three particles P, Q and R of masses 0.6, 0.4 and 0.8 kg are respectively at rest in a straight line on a smooth horizontal plane. So there is no resistance. The distance from P to Q is 3 meters and then again 3 meters between Q and R. P is projected directly towards Q with a speed of 3 meters per second. So if it is projected by 3 meters per second towards Q, right, this way, since there is no resistance, it started with 3 meter per second, it will reach 3 meter per second because before collision. That's what it means. Okay. After P and Q collide, P continues to move in the same direction with speed 1.5 meters per second. This P continues to move. Obviously, Q will also move this way. Otherwise, it cannot jump over Q and then move that way, right? So both are moving this way. That means find the speed of Q after collision. So we'll use conservation of momentum in this case. So what is conservation of momentum? M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2, that is conservation of momentum. M1, the mass of the first body is 0.6, which is moving, projected with what? 3 meter per second. Second body is 0.4 kg but stationary, and then they don't become one body, they remain different. So 0.6, but it is moving with 1.5 now. We don't know what 0.4 body is moving with, so we'll keep it V2. This is 0, we'll ignore it. It will be 1.8. Yeah, and this 1.5 times 0.6 will be 0.9, and I'll bring it to the other side, becomes negative, and we are left with 0.4 V2 here. Okay, so V2 will be 1.8 minus 0.9, 0.9 divided by 0.4, which will be 2.25 meters per second. That is the speed of Q after collision. Okay, in subsequent collision between Q and R, of course Q will be faster, Q is faster than, right, it is 2.25, and V1, the first body P was moving with 1.5, so it is faster, it will collide with Q first. Okay, so Q and R become one body, they coalesce. Okay, find the speed of the combined particle after this collision. So since there is no obstruction, it's a smooth plane, this particular body will keep on moving with this speed q, and it will hit r with same speed. So we'll use the same formula but with a difference, which will be m1 u1 plus m2 before collision. This will be the situation. But after collision, because they coalesce, they become one body, we will add their masses and they will have a constant speed, and that's what they're saying. Find the speed of combined particles after this collision. So m1 in this case is q now. What is the mass of q? 0.4. What is its speed? Is 2.25. The mass of body r is 0.8 kilograms. So it is heavier. So we will write 0.8 and it is stationary. But after collision they become one body, so we'll add their masses and we want to find at what speed will they move after this, which is 0.4 times 2.25 will be how much? 9. 4.5, 9, yeah, 0.9. This 0 equal to 0.4, 1.2 v, okay. So v becomes 0.9 divided by 1.2, which is 3/4, 0.75 meters per second. This is the speed at which both bodies becoming one body q and r moving at, okay. So we have a third part also, which says find the time it takes from where the P started initially projected until the instant where P collides with the combined particle again. Okay, so first let's find the time between when P starts and collides with Q. Okay, the distance between them was 3 meters. 3 meters. So 3 meters, and the speed at which P was moving and not changing that speed was 3 meters per second. So obviously 1 second. If the speed is 3 meters per second and the distance is 3 meters, what will be the time? Let's call it T1. 1 second. Okay, 3 divided by 3. In 1 second it will go and collide with Q. In second part, P is moving, but Q has already moved ahead. So now P is moving, but Q is moving faster towards R. Right? Now the time it will take for Q to reach R is 3 meters again, but the speed of Q is 2 point, not 2 point, is it 2.25? Let's see. The speed of Q is, yeah, 2.25, right? 2.25 mean. And again, there is no obstruction in between, so it will cover this 3 meters in how much time? T2 time. Let's call it T2. So T2 is the time taken by this, which is 3 meter divided by 2.25 meters. Okay, which comes out to be how much? 1.333. So basically 4/3 seconds. Okay, now finally this P is moving towards Q, and Q plus R has become a body, right? And that body is moving with 0.75 meter per second, and this P is moving with 1.5 meters per second. Okay, so we will see that in 4/3 seconds, when these Q and R collided, right, how much P had already moved, right? How much distance it had moved. So we know the distance is speed times time, the speed of P, speed of distance of P, speed of P. We are focusing on P only, but time we are taking when they Q and R collided, because at that moment where had P reached, that's the thing I want to see. Okay, so the speed of this is 1.5, so 1.5 times time is 4 over 3, 2 meters. So let me go back to, rather let me draw it here. So P and Q collided here. Then after 3 meters, R was there. Only Q came and collided with this. By that time, when this Q collided with R, P had reached 2 meters. It had covered 2 meters here. And we know till this moment, we already know the time, 4 over 3 and 1 second. So we will not count this time anymore because we have already counted this 4 over 3 here. But this 1 meter, it has to cover. This P has to cover. And now this Q and R together, they are moving at 0.75 meters. But P is moving this way 1.5 meters. So this meters per second. This P is faster than this. Obviously, it will collide with Q and R. Right? And now we have to see that in how much time this particular P will cover this difference of 1 meter and collide these two Q and R when there is somewhere. We don't know how much, where. Okay. So let's call it someplace. Okay. So how much time will it take to cover this 1 meter plus X? All right. So the time taken by Q and R will be X divided by their speed, which is 0.75. Same speed, same time will be taken by P, right, to collide with them. So that will be same as, but it will cover more distance, X plus 1 meter divided by 1.5 meters. So this will give us X, right? So now let's make some space here and cross multiply. I hope you understand. I'm trying to be as clear as possible. So 1.5x equal to 0.75x plus 0.75. So 1 minus 1.5 minus 0.5, 0.75 x equal to 0.75. It means x equal to 1 meter. It means 1 meter P has to cover plus 1 meter more, that makes it 2 meters, right? So 2 meters divided by how much speed? Speed is 1.5, right? Will be the time T3. We got T1, we got T2, and finally T3 will be this, which will be again 4 over 3. So total time, the one they're asking, is 1 second plus 4 over 3 plus 4 over 3, which will be 3 plus 8, 11 over 3 seconds. Question 6. A block of mass 12 kg is placed on a rough plane, okay, at an angle of alpha to the horizontal, where alpha is tan inverse 0.5. A force of x newtons is applied to the block, obviously upwards. They have not written where, but yeah, we can see upwards. Oh, up the plane. The coefficient of friction between block and the plane is mu. It is given that mu is 0.15, x is 20. Okay. Find the time that it takes for the block to move 2 meters down the plane from the rest. Okay. So from rest, right? So if we use v square equal to u square plus 2as, do we have everything? 2 meters and rest. So we can find the velocity, right? But they're asking time. So we can find time also after that. That means if we find somehow acceleration, we'll be good. So let me start here. We know that net force, which is mass times acceleration, is the difference of applied force minus resistive force. This mass of this particular one is 12 kg. Acceleration we want to find out. Applied force is this x Newton, but we will not take it as this. Why? Because it's moving down. We want it to move down. Even though this x being applied, but the force that takes it along in the direction of the motion is called applied force. And what is the force that is taking it down? It is the component of this weight downwards, which is always the weight, which is this way, 120 newtons, sine component of that weight, sine alpha. That is the one which is taking it down. But this x is stopping it, so it becomes resistive force as well as friction. Isn't it? Friction is always opposite to the motion. Since the motion is in this direction, the friction will be in this direction. So we will write it now. Applied force is 120 sine alpha. In place of alpha, we will write this. So 120 sine. There's no need to evaluate what is alpha by putting this in your calculator, okay? Just input tan inverse alpha, this is angle, okay? Minus, we know x, and we know it's friction. The two resistive forces. And this is what we will try to find out now. We don't know x. No, we know x is 20. We don't know f. So let's find f here. The frictional force is always the multiplication of the coefficient of friction and the normal contact force, which is called R. So let's say this component, this was sine component, this will be 120 cos component of the weight. So same will be upwards also. Why? Because there is no other force which can balance this. This box is not sinking in or flying off. That means these two forces are equal. So R is exactly as 120 cos alpha. So it becomes 0.15 times 120 cos alpha. Alpha is tan inverse 0.5. No, yeah, 0.5. That's what I will write. And now I wrote tan inverse 0.5. I should have written here, not alpha. Okay. So now I'll put x's value of 20 newtons and f's value of this, and I will get my answer, and I will do it here. Okay. So 12a is equal to 120 sine inverse tan in, not sine inverse, sine, just sine, tan inverse 0.5 minus 20 minus 0.15 times 120 cos tan inverse 0.5. Okay, and we have to find acceleration. So acceleration will be this minus this divided by 12, and that's what I will use in my calculator. And by the time I do this, I would request you to like this video, share with your friends, and subscribe to Math United. What I'm getting here is A equal to 1.46 meters per second square. So this whole thing in calculator, whatever it gives, divided by 12, and we'll get A. But our question was the time it takes to go 2 meters, and which we stopped here. So we will just write here. So v square. Rather, if we know this, then we can write s equal to ut plus half at square. This is better. Yeah, because this will give us time. So s is 2 meters down. U is rest. It's starting from rest. U, time we don't know, plus half, and we just got the acceleration as 1.46 t square. So this is gone. We can cross multiply now. This 2 multiplied by 2 is 4, and divided by 1.46 equal to t square. So if we want to find t, square root both sides. That's it. That will give us the time. When I put this in my calculator, I get a big number, but I'll round it off to 1.65 seconds. Let's see if there's a B part also. It is given instead that mu is not 0.15. Okay, it is different now. And x is 10, it is reduced. The block is on the point of moving down. This is very important. Why it is important? Because it will give us the idea that if it is moving down, the friction is up now. So the x is going upwards, which is 10 newtons now. The friction will also be up. Oh, it was also already upwards. Yeah. Oh, the same thing again. Okay, okay. So the friction will also be this way. However, the downward force remains same, which is 120 sine alpha. Okay. So we have to find mu this time, and since it is on the verge of moving, it is not moving down. That means this force and this force are equal. That's why it is not moving down. Acceleration is 0. Okay. So we'll just make up an equation out of this. 120 sine tan inverse 0.5 equal to 10 plus mu times 120 cos, and alpha is same thing, tan inverse 0.5. Okay, so what is unknown in this one? Only mu, right? So I'll just do it one by one step. So it comes out to be 53.6656. Let me write this bill. 53.6656 minus 10. This 10 will go there, equal to mu, and this 120 cos alpha, in place of alpha I wrote tan inverse 0.5 again. It came out to be 107.33. Okay, so mu comes out to be 43.6656 over 107.33, which is, by the time I use my calculator, I would request you to like this video, share with your friends, and subscribe to Math United. What I'm getting is 0.40683, so I'll write it 0.4073 signal figures. That is the value of mu. And the value of x, for which the block is on the point of moving up. Okay, they have another thing. Usually they should have given two parts. I was about to ignore this one. So I have to find when it is moving up. So since it is moving up, that means the friction will join the downward force now. So in that case, x will be upwards, but 120 sine alpha and mu r will be downwards. That's what will make it moving up. So x is equal to 120 sine tan inverse 0.5 plus, and now we all know 0.407 is mu, and then we'll write 120 cos tan inverse 0.5. All right, so this came out to be 53.6656 plus 0.407 times 107.33. It comes out to be 97.34891, so I will write it 97.3 newtons. 7. A particle moves in a straight line. The velocity v meter per second of the particle t seconds after leaving a fixed point O. Okay, so this is the point O, and it is going in a straight line. Okay, is given by v. So that's the velocity given. Let's open this. It's 20k plus pkt minus 6kt square. Okay. The acceleration of the particle at t, okay, so they want us to convert this to acceleration equation. T equal to 1, the acceleration is 42 meters per second square. What kind of particle is this? 42 meter per second square is the acceleration. Anyways, so acceleration is the rate of change in velocity with respect to time. Yeah, so we'll just differentiate it with respect to time. There's no time here, so 0. There is 1, so pk will be the differentiation of this because it is t to the power 1. So 1 comes here, multiplies, and 1 goes down, t to the power 0, which is 1, so there's no need to write t anymore. Minus 2 times 6, 12, k, t, and 2 minus 1 is 1, so we don't write it. So this is acceleration. Since they have given that at t equal to 1, it is 42, the acceleration is 42, so we will just utilize this to make an equation. 42 is equal to pk, is pk, minus 12k, and t is 1, so 12k. This is our equation number 1. Okay. Second, and displacement of the particle at t equal to 1, same t equal to 1 is 93 meters. So we will integrate this to get displacement. Integrate velocity equation or expression for velocity. Let's put k outside. 20 plus pt minus 6t square. We have to integrate this to get displacement. So it will be 20t plus pt square over 2 minus 6t cube over 3 plus c. From O, time was 0. It started time here. And displacement was also 0 because it passes from O. So we'll use that to find c first. This is displacement. So when t equal to 0, s is equal to 0. So k 20 times 0 plus p times 0 square over 2 0 plus 6 times 0 cube over 3 0 plus c. So everything is 0, so c is also 0. So c is insignificant here, so I can write it without c now. And now I'll substitute this one, t equal to 1 when s is 93 meters. So 93 equal to k 20 times 1 plus p 1 square over 2, so 1 over 2 minus, this can cancel, 2 1 cube, so 93 equal to 20 minus 2, 18k. 18k plus 0.5 pk. That's our equation number 2. So can I use simultaneous equation? I will try to eliminate one of them. Let's eliminate this pk so that we get the value of k. Yeah, we have to show that this. We can't use this, but we have to arrive here. So let's multiply this whole equation by 2. So that this becomes 1 pk, which is 1 pk here. Alright. So 2 times 93 is 186. I'll write 186 here. 2 times 18k is 36k. I'll write 36k here. Positive, positive. And then pk. So we'll subtract this equation so that pk gets cancelled out. So it comes out to be how much? 144 negative. And this comes out to be negative 48 k. So k is negative 144 over negative 48. Obviously it is equal to 3. That's what we have to show. And now we have to find p equal to 26. So we can use any one equation. Let's use this equation number 1. 42 equal to p, and now we know k is 3, minus 12 times 3, 36. 36 goes to the other side, to 42 plus 36, 78 equal to 3p, and p equal to 78 divided by 3, which is 26. That's it. We showed it. K equal to 3, p equal to 26. Okay. We have another part for this. Find the distance moved by the particle between time at which its acceleration is 0 and the time at which its velocity is 0. Okay. So we had an expression for acceleration already, which was this. Pk minus 12k t. Pk minus 12kt. So A equal to Pk. P is 26. K is 3 minus 12k. I hope 12 kt. Kt is there. So K is 3 and T. Acceleration is 0, they are saying. Acceleration is 0. So we will put this as 0. So 78 minus 36t equal to 0. 36t equal to 78. T equal to 78 over 36. So can I, yes, 6 and 13 times 6. 13 over 6. This is the time when acceleration is 0. Now, when velocity is 0, and the equation of velocity, I'll have to go back again and see what is the equation of velocity. It was this: k 20 plus pt minus 20 plus pt minus 6 t square. K 20 plus pt minus 6 t square. Sorry, I'll have to see once more to make sure. 20 plus pt minus 6t square. 20 plus pt minus 6t square. Yeah. This is velocity, and they said this is equal to 0. And we have to find time. So 0 equal to k was 3, 20 plus 26t minus 6t square. So 3 cannot be 0. That means this whole thing is 0. Then only we can have their multiplication as 0. And all of them are even, so we can even simplify this. So it will become minus 6t square plus 26t plus 20 equal to 0. And I will divide this by minus 2. Every one by minus 2. This was positive, right? So it becomes what? 3t square positive minus 13t minus 10 equal to 0. Minus 15t plus 2t minus 10 equal to 0. 3t t minus 5 plus 2t minus 5 equal to 0. So 3t plus 2t minus 5 equal to 0. So this gives me t equal to minus 2 over 3 and t equal to 5, and we cannot use the negative time, so reject this one. T equal to 5 we'll use. So now we know 2 times 13 over 6 and 5. Which one of them is smaller? This one is smaller. And we will find the distance by using the integration we had done already, which was this. This was integration, right? This one. I will use this one. Let me use it here only. Okay. So I will use this. S was K. K is 3. 20t. And P came out to be 26. So it will be 13t square minus 2t cube plus c, and we want from 11 over 6, no, 13 over 6 and 5. These are the two times between which we have to find the distance, 13 over 6 and 5. And I hope there is no turning point between them, which was, where was turning point? V equal to 0. Let's see, where was V equal to 0. Let me just ensure that V equal to 0 was, okay, it is at these two times, which is not between these two times. This is the corner of this, so no, don't worry. If there was a turning point, there would be a problem, but in this case there is no turning point. We'll just substitute this. Okay, so answer will be 320 times 5 minus plus 13 5 square minus 2 5 cube plus c minus let me bring this 3 here only. Okay, so 20 times 13 over 6 plus 13 over 6 square minus 2 13 over 6 cube plus c. Many of you object why I write c all the time, whether it is when it is not needed, but it's a habit, and I know c exists. It is not part of the definite integral, but it exists, so it's better to write it and then cancel it out. Okay, so 3 100, this one is 100, this will be 25 times 13, so 275, no, 325 minus 125 times 2, 250 minus, and now I'll put minus without, this will become positive and these two will become negative. So 260 over 6 plus 169 times 13 over 6. Oh, and then 13 cube, it will become positive, and this was negative, sorry. This was negative, this is positive. And 2 times 13 cube, I'll put this in my calculator. Okay. One mistake I made, which was this, that it should be 36, not 6, because 6 is also squared. And it comes out to be 272.9444, which will be almost 273 if we round it off to 3 significant figures.